Hi everybody, Mr. Rubo here. Today we are still looking at 310 trig equations, but now we're going to look at raising trig equations to a power. So, little notation here. If you want to square a trig function or raise them to any power, we don't want to we want to make sure our notation is very clear. So whenever you want to raise the entire trig power to any power, right? So you can see power n here. We always write the power actually right after the trig function. So here you can see it's sine to the nth of x, because you don't want to think, okay, am I raising x to that power, or am I raising the sine of x to that power? So we lose that ambiguity by just putting the power in after the trig function and before the x. So you can see here, sine of x all raised to the second is the same as saying sine squared x. So let's do an example where we have some squaring, because the work is actually very algebraic until the very end, and then you worry about the sign, right? Then you worry about the trig. So here, function g is given by g of theta equals 3 minus 4 sine squared theta. We're looking for the zeros, and they are restricting us to just the first rotation of a circle. We don't want all the answers, we just want 0 to 2 pi, so no general solutions here. So zeros mean set the whole thing equal to 0 and solve. And this is what I was talking about, where this is all very algebra, right? There's when we start doing this, you'll see we're going to do what you would expect to do in an algebra class. It's just then we end up with a sign at the end. So we're trying to get theta by itself. So let's start moving stuff around, manipulating this. So I'm going to subtract 3. And then I'm going to divide by -4, right? And again, so far, nothing has been out of the ordinary for algebra. Remember, 2 negatives make it positive. Now, still nothing out of the ordinary. You have something squared. Well, we want to square root both sides. Now, again, you should put your plus or minus in the front. And then as far as simplifying radicals with fractions in them, this is kind of the property we're going to use here, that if you have a fraction inside your radical, you can separate it. Okay, that is what we're going to use here. So I can simplify this to plus or minus the square root of 3 over the square root of 4, which we can simplify to 2. And that equals the sine of theta. So now I'm actually going to think of these as two separate equations. I have the sine of theta equals root 3 over 2, and the sine of theta, actually I'm going to do it in a different color, sine of theta equals negative root 3 over 2, which ends up that because these are the ones where we're drawing triangles and they're not on the quadrant, on the axes, I should say, we're going to actually have 4 triangles. We're going to get 2 from this one. The positive sign is those 2 quadrants, root 3, 2, root 3, 2. But then this guy's giving me the 2 negative answers. So I'm actually drawing 4 triangles that are all very similar to each other. They all end up being pi thirds as their reference angle, which, again, all of them the same. So now I just need to say all those answers. So from the 2 positive ones, I would get pi thirds and 2 pi thirds. And then from the red ones, or I guess that's orange, I would end up getting the 4 pi thirds and the 5 pi thirds. And there's my answers. I don't want the general solution here because they want just between 0 and 2 pi. And I also want all the positives. So yeah, there's my 4 answers. And when you get these plus or minuses, usually you end up with 4 answers because you're getting both sets of the positive and both sets of the negative triangles. All right. Well, thanks for watching and have a good day.